We've had some brilliant speakers in the past. I'm delighted to say we've got another pair of really great speakers that will provide some really interesting insights into the market as well. So first of all, I'd like to introduce Jamie Snudden, who is from Airborne. He's the business development manager for the UK. So Jamie, if you don't mind, I'm going to give you a bit of a brief introduction for those who might not know you as well. So
Sure.
Enthusiastic about both new aviation and helping to reduce global emissions, both Jamie and Airborne support advanced air mobility businesses to develop their airframes from initial concepts through to serial production. With a PhD in aerospace engineering, looking at recycling of composite materials, and an MBA, Jamie's interest lies in both the technological aspects of novel aerostructure development and the entrepreneurial and strategic aspects of a rapidly growing market. Airborne is making good progress in this market, and Jamie's going to talk about composites industrialisation, as well as the challenges of scale-up and industrialisation, and some solutions as well. For those who haven't been to these events before, you will see there's a Q&A section on the sideboard. If you're able to put some questions in for Jamie to answer during his presentation, and we'll make sure we answer them before we get on to the second presentation. So Jamie, enough of me talking. Really looking forward to your presentation. If you'd like to share your screen, the floor is yours.
Absolutely. Yeah, thanks for the introduction. That's definitely flattered my ego significantly. So yes, hopefully you can see my screen now. What I'm going to talk to you all today about is the challenges and opportunities that are represented by the eVTOL industry. And I think over the last couple of years, there have been a lot of presentations, a lot of literature written about a variety of challenges that I think we all know about. But one which hasn't really been spoken about yet is how to get from where we are at the moment, which is moving from conceptualization, design, onto prototyping, and then on to the next stage after that, which is serial production. And based on the numbers being quoted by the OEMs, both in terms of production rates and cost targets, this is going to be a significant challenges. So I'm going to discuss the challenges, but then there is also light at the end of the tunnel, and there are some opportunities that are coming out of that as well. So moving forward, I thought I'd start with a bit of giving a bit of context around what eVTOL and UAM and logistics actually mean in the context of new transport. And what we're seeing is a significant change, particularly coming out of the pandemic, in thinking around what transport actually means. Prior to that pandemic, it was very much the same methods of transport have been used for the last 70, 80 years. But now we're rapidly seeing new forms of mobility, things like e-scooters that are being trialled around the UK and around the world, which are replacing short car journeys in cities, which, I mean, where I'm based in Bristol, it's already having an impact on congestion, on emissions. And we can see that moving up through the sizes of vehicles. So things like last mile delivery and all the way through to eVTOL and large drones and onwards. So this shows there's a real willingness for consumers to take on new sustainable modes of transport. And obviously there's a big difference between micromobility and a flying aircraft, but that's really encouraging. So moving on to the challenge that I'm really focusing on in this presentation, and I think it's highlighted by this slide, where there are many more examples, but the examples that I've highlighted are numbers quoted from investor decks that I've seen. So anything from 400 units per year at $2.5 million a unit, up to 2,000 units per year at $1.6 million per unit. And although it's not quite comparing apples with apples, the current rate of production for vertical takeoff vehicles are somewhere around the 50 to 100 units per year per OEM, and that's at a unit price of around $3 million. So this represents a real challenge to actually go from that prototype, that niche market, into widespread use. So just in context of all the other barriers, we've seen most of these, and in previous eVTOL Insights presentations, we've seen a lot of discussions around them. Everything from product differentiation, access to distribution, and we're starting to see vertiports and other such infrastructure being looked at and trialed. Capital requirements, there's an awful lot of funding coming into the markets at the moment. It's going to be an interesting one to see whether that actually carries on past the prototyping and the certification phase. Is the capital still going to be there when it comes to actually bring these to widespread use? Concurrent reaction, I don't think there's too much of a challenge there. The differentiation between eVTOL and other modes of transport are such that eVTOL and UAM are going to be augmenting existing transport modes, not replacing them. I won't touch air traffic management. It's an interesting one. But the ones that again, I'm going to focus on are absolute cost and economies of scale. And these are two interlinked challenges. Absolute cost is already coming down, and the use of electric motors and electric powertrains is drastically going to reduce the operating cost. It's the unit cost which is a challenge, and being able to access the economies of scale during production, that's where those savings can be made. So the criticality of those barriers are going to change as we move from where we are now through to serial production. And apologies if I've missed off your favoured OEM here, but I was running out of space on the slide. So at the moment, moving from design to conceptualization, capital requirements and legislation were the key ones. Can we get experimental aircraft to fly? Where's the money going to come from? We've covered those. Differentiation, that's starting to become important. It's already a congestion market, and we're seeing more OEMs come online. So it's going to be an exciting competition over the next couple of years. As we move into entry into service, the incumbent reaction and modes of distribution, that's going to be more important. And then finally, as we get to serial production, that's when the cost and the scale become really critical. The trouble is, although that's in the future, we need to start looking at those challenges now. And I've tried to illustrate this in this slide. So with traditional automation, and here I'm specifically thinking about composites automation, which is where Airborne's area of expertise is. Traditionally, aircraft development programs and automotive development programs are long enough that there's time to develop the automated production processes either during development or during the ramp-up phases. So that means there's no gap in between needing to think about automation and production and the end of the design phase. The trouble with the eVTOL is we don't really have time to do that, and the rates are so high, or the forecasted rates are so high, that actually waiting until serial production to start implementing automation and developing automation will actually be too late, and there's never going to be an opportunity to catch up with the demand forecasted in the market. So really what needs to happen is automation and production development needs to start earlier. And this is also the case because the requirements by eVTOL are very different from traditional aerospace and traditional automotive. So in traditional aerospace, the quality is very high, production rates are reasonably low, and cost is very high. And it's pretty much the exact opposite in automotive, where cost is key, very high production rates are needed, quality it needs to be appropriate for the vehicle being designed. eVTOL sits somewhere in the middle, so quality obviously needs to be up at aerospace levels because it's a flying vehicle. Production rates are going to be significantly higher than aerospace, traditional aerospace, but not at the same level as automotive. And again, that cost level needs to come down to be able to hit those unit cost targets. So that's quite a challenge, but there is a solution. And this solution has, this whole concept of concurrent engineering has been around for many years. And I've got an example coming up where I can show you that. But the whole idea is that during the design phase, 70% of the costs of a component or an airframe or a product are locked in, which means that later on, automating or manufacturing the product becomes more difficult and more complex. So the general idea is bring that production development earlier on, so you can iterate with the design team to make sure that the end product is optimized for manufacturability, cost, production rates, and so on. So this is a way that we've or a method that we've developed and conceptualized at Airborne to try and combine the product development process with automated production process development. So you can see in this flowchart here that the product development process runs from requirements through to material selection, preliminary design, detailed design, and then on to serial production. System development takes a very similar approach. We start with getting the requirements, move on to preliminary design phases, which in this case we call the system architecture definition, and then on to detailed development of individual processes. So these can actually run in parallel. And by running them in parallel, you can have a lot more iteration in between the two design processes. So you end up with a more optimized product that can be manufactured more easily in collapsed timescales. And this has been done many times before, and a good example is in the Second World War. The Hurricane was a lot easier to manufacture, so a lot more were produced at a lot lower rate than a lot higher rate than the Spitfire. So there was a trade-off between the two. The Spitfire was high performing, but the Hurricane could be produced more quickly and more cheaply. So taking a very similar approach, but using automation, means that trade-off between performance and costs can be changed to a certain extent. So this is where Airborne's capabilities lie. We've developed a set of capabilities that means we can support anything from initial product development and process development all the way through to serial production or providing automation. So we're based in the UK and the Netherlands. We've been going for about 40 years, and we've got about 140 employees. And we've done everything from automotive through to marine to aerospace, and any new market is very interesting for us. The way that we can support is, as I say, anything from initial design and development all the way through to serial manufacture, low volume manufacturing in between. We've got a low volume production site in the UK, and then we can either provide automated solutions to customers or partners, or carry on manufacturing ourselves. And the way that we do that is that we've got these sets of this capability set. I think that's all the slides that I have on sales. So hopefully this will carry on being more interesting. So prototypes are very important, and at this point, when you're prototyping, that's when you can have some influence on the design still, and so we can definitely work on design for manufacture there. And something that we're working on in parallel is automated manufacturing solutions, so they'll be ready for when UAM gains certification and entry into market. So this particular video, which I've sped up for the purposes of getting through it in the presentation, shows the manufacture of rotor blades. So just to finish off, by moving this traditional automation development stage back towards the design stage of the product, we end up with something that looks a lot more like a lot more realistic to actually reach the production rates that are being forecasted by OEMs. And what this does is it means that supply can keep up with demand. And in a market like this, where there are multiple competitors, if you can't keep up with demand, there's room for another competitor to come in and steal some market share. And the same happens with cost. So if you try and automate and optimize production after you've frozen the design, then unit costs may reduce slightly, but not to the levels required. So by incorporating automation and production development during the design phase, there's an opportunity there to reduce costs and hit the targets that are being forecast. So finally, the last opportunity that I'm going to talk about is supply chain emissions. Global supply chains aren't green, so there's an opportunity in a new market to make sure supply chains are designed to reduce their length, minimize the amount of transport required in between processes. So for a production or a supply chain to be truly green, then there's an opportunity there to incorporate automation and reshore production. So that's it. I'll be hanging around afterwards, so come and find me. Otherwise, drop me an email or send me a LinkedIn message.
Awesome, Jamie. Thank you ever so much for your presentation. Really interesting, and certainly I'm sure there'll be a lot of other follow-on questions as a result of the presentation you had today. We have got 2 questions, so I'd just like to start very quickly before we go into Stefan's presentation. The first question is from Robin Brownsell from FlightCrowd. Robin, thank you very much for the question, and he's asked, Jamie, are investors happy to support financially the extra costs of concurrent engineering?
That's a very good question. It's conceptually, yes, they like the idea of it. And some of the more advanced UAM OEMs that we've spoken to are keen for it, because in the eyes of an investor, it does show that the company is forward thinking and looking to reduce costs later on. The challenge is the very early stage startups where that funding may not be available. But generally, there is a certain cost implication, but that can be mitigated through other means.
Perfect. Thank you very much for that, Jamie. And the final question we've got is from Daryl Swanson. Is how do we apply a concurrent engineering approach to end of life for eVTOL and or EC or eSTOL? There is a lot being said about the recycling of battery components. What about recycling composites?
I'm glad you asked that question. That's an area of real interest for me. The challenge comes actually at the material selection stage. So there's new materials that can be used that are recyclable. So you've really got to have a recycling mindset right from the get-go. The challenge comes with the timescales. So more traditional composite materials are already qualified, de-risked to a certain extent. So the certification bodies look slightly more favorably on them. The trouble with those more traditional composites is that they're more difficult to recycle. And it comes back to as you say, the concurrent engineering approach. And it's a problem in the commercial aerospace industry at the moment with the 787 and the A350 in 30, 40, 50 years time, when they get to the end of their lives. There's a hope that there's going to be a recycling process that can deal with them. So one is material selection. Try to choose more recyclable or more easily recycled composite materials. And the second one is designing structures that can be taken apart more easily, and things like metallic fittings can be removed more easily, because that's, again, one of the serious challenges with recycling is just sorting and separating out different sorts of waste.
Great. Thanks ever so much, there, Jamie. We've got one final question, and that will be it before we. I've just seen that Ettore is unfortunately. Thanks ever so much for the question, Ettore. We might have to just skip, but I'm happy to put your question to Jamie, and I'm sure he'll be able to answer after the presentations as well. Final one, Jamie, is from Tim Shattuck, who said, "Are the certification and entry into service dates realistic given the new technology regulatory resources?"
It is if OEM starts to look at it now, because there's brand new technologies that are just coming onto the market, manufacturing technologies that are coming onto the market that may not be ready in time, but there's existing technologies that can be modified and upgraded, which have either already been qualified on an aerospace manufacturing process or are about to be. There's a slight trade-off there, so it may be that the design has to be changed very slightly to be able to be manufactured on that equipment. But in that case, that kind of 2-year timescale that we're looking at to certification of the first aircraft is possible.
Brilliant. Thanks ever so much for that, Jamie. Really appreciate your presentation. As I mentioned, everyone, Jamie will be sticking around until the end. So if you have any other questions, Ettore, I'm sorry we didn't get to answer your question, but I'm sure Jamie will be able to answer that afterwards as well. Jamie, thank you again. If you're able just to turn your camera off, and Stefan, if you're able to jump up onto the stage as well to take Jamie's place, we can begin your presentation.
Yes, hello.
Brilliant. Thanks ever so much for joining us, Stefan. And yeah, apologies for having to wait a little bit before jumping on. We had a few good questions from the audience as well. So for those who don't know Stefan, he's driving strategy, definition and execution for Rolls-Royce's electrification efforts in new emerging markets like urban and regional air mobility. He joined the Rolls-Royce team in 2019 with the acquisition of Siemens E-Aircraft, where he previously worked as innovation manager, and he holds a master's degree and PhD in engineering. So Stefan will be talking a bit more about what the company is doing in the market. So Stefan, without further ado, very much looking forward to your presentation. If you'd like to share your screen, the floor is yours.
Perfect. Thank you very much, Jason. I'm really happy to have the opportunity to share with you a little bit of what we're doing at Rolls-Royce Electrical. So if I have that figured out here, you can see my slides now. So I want to talk a little bit about how we are supporting advanced air mobility and how we're powering advanced air mobility. I would like to focus a bit on where we sit in the broader Rolls-Royce group, as many of you might know Rolls-Royce, but maybe struggle a little bit to understand what Rolls-Royce Electrical is doing. So I want to cover that a little bit, then show you what we're doing in advanced air mobility, and as well highlight some of the challenges we see for the industry and how we want to support that. So to get started, so Rolls-Royce Electrical is a business within Rolls-Royce. So actually, you will definitely know Rolls-Royce from civil aviation, from civil aerospace. We as well have a defense business and power systems who's looking at stationary and other mobile land and sea applications. And since of the 1st of January this year, Rolls-Royce Electrical is a business next to the other businesses. And our director has been promoted to the executive team. So we now get the recognition that electrical is actually a business of its own and not only a capability within a broader group, which is an amazing sign that the group has confidence in what we're doing. Overall, on group level, if I just start a little bit with what's our priority on the Rolls-Royce group level. Mid of last year, I think it was in June, we've published our net zero strategy. And we have really focused our strategic initiatives and all the business strategies on reaching net zero and championing sustainable power, how we call it. Actually, that claim we started already in 2017. Back then it was called Champion Electrification. And as the group recognized the importance of electrification going forward, some strategic moves were made. For example, acquiring the Siemens E-Aircraft business in 2019, which was how I came on board. Previously, I worked in this with Siemens in the Airbus-Siemens collaboration. But Rolls-Royce already had identified the importance and acquired the unit. And this was when we were able to build up then Rolls-Royce Electrical to a team at the time of around 350 people. Now we are already at around 450, approaching the 500 quite soon. And but over the time, it became quite clear that electrification will be one important building block to achieve our sustainability targets. But the group is really looking at all the technologies you will need and all the solutions. So next to electrification, we have a strong focus on hydrogen and sustainable aviation fuels, and as well nuclear with a small modular reactor business that we've just spun out of Rolls-Royce recently. And we're looking at all these technologies because we see that for our ultimate goal, which is the decarbonization of aviation, we need to, there is no silver bullet. There is no one solution. We will not solve the challenges just with electrical technology. It's actually we've tried to map that out on this roadmap. It's really a portfolio of solutions and technologies we need to look at. We see that all electric technology will be useful for the smaller aircraft, from small propeller aircraft, urban air mobility, the commuter space, maybe up to 19 seat. Then we quickly will see the hybrid electric systems using gas turbines, in the future combusting kerosene, or ideally sustainable aviation fuel or hydrogen going forward. We see a place for hydrogen fuel cells. And then if you look to definitely the segment where you almost find every technology is the regional aircraft space. Here it's a really interesting space where we are exploring fuel cells, also as direct combustion of hydrogen and gas turbines. We see that larger aircraft will require more electric technologies. So it's really a lot of different solutions. There is no silver bullet yet, but I think it's quite important to share that even though we're really vocal about our electrification efforts, we're looking at the bigger picture, and we clearly understand where the big carbon emitters are in the aviation industry and try to tackle that. However, today I would like to focus on the electrification efforts through Rolls-Royce Electrical, because this is it is a contribution to more sustainable aviation, but it's equally an exciting field where we see new business opportunities that improve mobility overall and how we think about aviation. And Rolls-Royce Electrical is bringing that together in the group. And what we are working on is to develop electric power and propulsion systems. So we position ourselves as a system provider to the industry. We have, this is based on our deep technological expertise. Actually, specifically with the acquisition of Siemens Aircraft, we brought on around 200 experienced engineers in electrical machine design, power electronics, controls, and system architecture, system design, and system integration. And this combined as well with the long heritage of Rolls-Royce, with the certification experience and understanding of things like thermal management, who are really important in electrical and hybrid electric systems. We really have all the technologies you need to develop full power and propulsion systems. And we're doing that in a way that we're working on a modular and scalable portfolio. So what does that mean? If we think about the whole advanced air mobility space, from small propeller aircraft to eVTOLs and commuter aircraft, there are some things which are a bit more specific. We see that an electric machine for a fixed wing aircraft is different than an electric machine for a eVTOL that requires as a lift application. But when you look at the power electronics, the distribution, the controls, the battery management system, these are all platform developments so that we can bring these into a broad range of applications and as well a broad range of markets. Just to give you some highlights of technology we're currently working on, I think probably we're not as well known as a company who's working on energy storage. So I really wanted to highlight the investment we're doing in energy storage technology. Last year, we've announced that we will invest a large amount of money into our energy storage program that will deliver battery advanced air mobility space, specifically for eVTOLs and commuter aircraft. We actually have already quite a lot of experience in that field. We've built various demonstrators. We've flown quite a lot of systems and batteries. Actually, you might have seen the Excel aircraft, the Spirit of Innovation, which just recently broke the speed record, achieving 555 kilometers an hour or 345 miles per hour. And that's basically a battery with wings. And we've learned quite a lot about high power densities, high power batteries, and the big challenges you have, for example, the thermal management and everything around that. So we've gathered a lot of experience on this and on other programs, and we're now bringing this into a development program that will deliver qualified batteries that are ready for certification for various applications. And we're designing that with certification in mind from the start. However, we understand the limitations of battery technology, and we are also working on hybrid systems. And for that, we're currently working on technologies for a new turbo generator that will be able to deliver range extension for advanced air mobility solutions. So, for example, for an eVTOL. We see that there are a lot of opportunities to reuse engines from helicopters, from current APUs, from large aircraft. But we see an opportunity to design a turbo generator specifically for hybrid electric applications. And to have this future-proof, we want to design it to be sustainable aviation fuel capable, and as well capable of burning hydrogen in the future. So this is something where we are currently talking to customers, trying to really understand the requirements, to understand what is the best product for hybrid electric applications to hit the market. And currently, for that new gas turbine, the ground run of a new technology demonstrator that should run on the test bench later this year. So just to give you a little with whom we're working in the advanced air mobility space. So I've already talked a little bit about the Spirit of Innovation, and here on the left-hand side you can see the beautiful aircraft, which is it's based on a kit aircraft. So it's the Nemesis XT, and yeah, was just an incredible opportunity to show the art of the possible with electric propulsion technology in a small airframe, really optimized for speed. We have, you can see in the middle, a collaboration with Vertical Aerospace. We will deliver the units for that vehicle and the power distribution, as well as the high voltage system design. This is a really exciting opportunity and our first customer in urban air mobility, but we are already in engagement with other OEMs really to bring our portfolio into the market. And in the commuter space, we're really proud to be part with Tecnam, the Italian plane maker, and as well in a trilateral setup with Tecnam and Widerøe, the biggest Nordic regional airline. The Tecnam P into the market by 2026. And we're here teamed up with Widerøe because we see a strong pull from Norway to bring this into applications. And even with looking at current battery technology and the limited range you will achieve with an all-electric aircraft, there are still a lot of routes and really good use cases, for example, in Norway, where these aircraft really make a lot of sense from an economic perspective and from a sustainability perspective. So we're really excited about these partners and these opportunities that we're pursuing. Now, I would like to, so I've talked about great technology and great partners that we have. Really would like to flesh out some challenges and maybe as well some thinking that we're doing beyond what we want to offer on the propulsion system side. So I think as well. Quite a lot was already discussed about things like public acceptance. We had, I think, really good presentations in the past on this. Certification is a really important topic. Today, I would like just to highlight two topics around infrastructure and service. So if we look at advanced air and the eVTOL space, so just focusing on eVTOLs, and if we take, this is now based on study from Porsche Consulting, and if we look at 2035 and we will have 13,000 eVTOLs in operation in a really global footprint, this will bring a lot of challenges. We will need, so for this base case assumption, this will lead to around 1,000 to 2,500 vertiports. And obviously at these vertiports, you will as well need charging infrastructure. And we see that fast charging with up to 1 megawatt, if you assume a certain level of operations of these vehicles, the energy demand quickly scales up, and that's actually really demanding, not only for an airport, but if you think about vertiports in an urban environment, that's really challenging. And another thing is the vehicles. So if you look at 15,000 vehicles being in operation, if you multiply that by maybe an average of 8 electric propulsion units, you will have around 120,000 propulsion units flying around in virtually any part of the world. So that's as well quite a big challenge. So we're doing some thinking around how can we support that and how can we help to solve these challenges. On charging, we are quite fortunate that in the Rolls-Royce group, we as well have the power systems business, who is focused on decentralized microgrid solutions, and is already providing infrastructure to airports for backup power or infrastructure to support fast charging of electric vehicles. And we clearly see an opportunity to bring this to support vertiport companies and airports who want to scale up this infrastructure. Now, I would like to highlight one topic, which is we would like to offer that in an energy as a service business model, so that actually the airport or the vertiport company could sign up for a service to get the energy or the power they need to charge the vehicles, and so that they do not need to invest upfront in large in high hardware cost. Because we understand that if you look at regional airports who will be used for these new vehicles, or even larger airports, it's quite difficult to get high upfront investments for a market where the ramp up of operations will be quite uncertain. So we see a lot of benefit in offering this in a different way than just selling hardware. And maybe my last slide on just some thinking around the service for these vehicles. So it will be quite a big challenge. And well, we sometimes hear people already talking about maintenance, but maybe not to the extent the industry should be talking about it, because we see this as something which is really critical. And we're currently working on, or we're exploring how we can our existing footprint and service that we have in power systems and in the business aviation world, for example, how we can leverage that to support the industry with our maintenance services, because this will be quite a big challenge if you look at the fleets that are forecasted even in the conservative base case scenarios. So overall, we're really technology focused, and we are focused on delivering our products into the market. But where we definitely want to and need to further engage with the wider ecosystem is to think about the infrastructure and the service, because this is where we clearly need to make this happen. So, and that's why I'm really happy that I had the opportunity to speak here. I think I've already talked a little bit too long. Hope we still have some time for questions. Thank you very much.
It's really well read out as well, and thank you ever so much for all the insights as well. Really interesting from that energy as service point of view as well. I've got some questions from Tom Freund. So Tom, thank you very much for that. He's got two questions actually. So get the first one first. Is he's asked, what's the differentiate between a battery management system in automotive versus aviation?
So, well, the biggest difference is the safety levels you have to achieve. So, well, I mean, this is something that can quickly increase the cost of the development. And you need to have that in mind when you start the development right from the start. The processes you use for the development, so that's a big differentiator. And that, makes it a different product in the end.
Perfect. Thank you very much for that. And then the second question she's asked is, how come that pure hydrogen fuel cell propulsion isn't quite suitable for larger aircraft?
So we will see that, well, we think that hydrogen fuel cells will have a place for larger commuter aircraft and then extending into the regional aircraft space. If you do the calculations, you will see that there is, at a certain size of regional aircraft, at some point you will reach the limit of what is doable, and then you might look at maybe directly combusting hydrogen. So there is from the physics, there is a limitation there.
Perfect. No, thank you very much for that, Stefan. And another question from Robin at Flightcrowd, who's asked, what is your plan to recycle the batteries?
So that's a really good question. So I think it will be important to manage the batteries properly, because if you think about an eVTOL, you will need to replace the batteries over the life cycle of the vehicle. And what you will have is not like if you think about your Tesla, you will drive your battery until it's finished. But for an aircraft, it will still be quite a good battery, because you need to maybe have it at 90% capacity retention. So you don't want to recycle that directly. You should think about bringing that into a second or even a third life application.
Perfect. Thank you very much. Ettore has put in another question. So I feel I need to ask this question, so we didn't get to answer this one for Jamie. And he's mentioned, Stefan, about the energy as a service. How do you produce the required energy in this concept?
So it really depends on the location where you will have the infrastructure, where you will have a vertiport, on what's available. So we see great benefit of having, for example, containerized energy storage solutions to buffer the energy to reduce the peak demand. And then it's really beneficial if you can include photovoltaics. So we've actually seen a lot of great designs from vertiports, including already having photovoltaics planned in from the beginning, because that makes a lot of sense. And if we think a bit further, people want to really be assured that if they fly with an eVTOL, that the charge is really coming from renewables and not from the coal plant nearby. So that's going to be really important.
Excellent. Thank you for that. And just to follow up on the energy as a service concept, another question is coming from Anonymous. So whoever you are that sent this in, thank you very much. And they've just asked, can you comment further on risk with energy as a service where demand isn't clear?
Apologies, could you repeat?
Sorry, Stefan. They've asked, can you comment further on risk with energy as a service where demand isn't clear?
Okay. Yeah, so obviously energy as a service would reduce the risk of, for example, the airport who needs to deploy infrastructure to be ready for these vehicles. And if the demand's not there, well, they would have a really big risk if they would have invested in the infrastructure. For us, it is really, you need to balance the risk, right? What I've highlighted on this slide is actually something we've announced at COP26 in Glasgow, that Rolls-Royce Power Systems has an agreement with a Sustainable Development Capital Limited fund who would invest in such propositions. So it's really something where we structure this in the way that the risk is shared and that is an investable proposition, and that helps to really build this up.
Perfect. Thanks, Stefan. A question I've got from Barbara Labar, so thank you very much, Barbara, is how hydrogen will be stored on board, liquid, or when a kind of standardized hybrid powertrain can be expected?
So in terms of hydrogen storage, we see that Well, on the lower end, you have compressed hydrogen, which has can be used up to a certain point. For larger aircraft, at some point you would need to switch to liquefied hydrogen. And there is an overlap where it's not completely clear yet. And for hydrogen, it's always important that you look at the full energy chain and how that's actually delivered, and how you have the conversion then and the liquefaction. So there will be both. There is a limitation for compressed hydrogen.
Perfect. Thank you. And then final question, again, just from Daryl. I'm just conscious of the time, just so we have a bit more time before the networking is. For your EAS system, so it's getting a lot of attention, Stefan, so thank you for that. Will it be able to feed back into the grid?
So that's one use case that we already have in other applications. So this is all technology that's already there in the portfolio of Rolls-Royce Power Systems. And yes, that would be a really good use case, which is as well a revenue opportunity.